lines, parallel and perpendicular lines. When we talk about parallel lines in the Euclidean plane, parallel lines are two lines that never touch. They'll never cross no matter how long you extend the lines. The only way this is possible is if they have the same gradient. Perpendicular lines intersect at right angles. That means that they cross at right angles. It forms 90 degrees. Now the gradients for these two are related in a slightly more complicated way. If you take the two gradients and multiply them together, the product that you get is -1. So if we call one of the gradients m1, the other one m2, multiply them together, we get -1. It's a nice little fact that will be helpful for a few questions, but it's more useful to be able to work out a perpendicular gradient. The way we do this is by working out the negative reciprocal. We just do -1 over the gradient, and it tells us the gradient is perpendicular. We'll have a look at an example to see how this is working out. We'll start off with a line, and this line has a gradient of 1/2. We're asked to find the gradient of the parallel line. So find the gradient of a line which is parallel to this line, which has a gradient of 1/2. Now what we said before is we said if two lines are parallel, it means they have the same gradient. So here the gradient is just 1/2. In the next part, we're going to be asking for find the gradient of the perpendicular line. So find the gradient of a line which is perpendicular to this one of gradient 1/2. How are we going to do this? We're going to use this negative reciprocal idea, and we're just going to do -1 over 1/2. Dividing by fractions is a little bit complicated. You could either take the bottom denominator up to the top, or you could multiply top and bottom by 2. Either way, this tells you you end up with -2 over 1. Simplifies down straight away to -2. Thank you.